Hello and welcome to Maths with Jacob. This lesson will focus on fractions to decimals. Terminating decimals are those that have a definite endpoint. They do not continue on forever. So let's have a look how we can change some fractions into terminating decimals. Express 3 over 4 as a terminating decimal. So we're dividing 4 into 3. So we can go 4 into 3.00. We put as many zeros here as we want. 4 into 3 goes 0. 3 left over, so you put the 3 there. Don't forget to put the decimal point down. 4 into 30 goes 7. Since 4 sevens are 28, there are 2 left over. And 4 into 20 goes 5. So 3/4 is 0.75. That's a terminating decimal, of course it doesn't go any further. Express 7 over 8 as a terminating decimal. So we divide 8 into 7.000. Remember, you can put as many zeros there as you want. 8 divided into 7 goes 0. Put down the decimal point, 7 left over. 8 into 70 goes 8. So 8 eighths are 64, so there's 6 left over. 8 into 60 goes 7. 8 sevens are 56, so there are 4 left over. And 8 into 40 goes 5. So 7 over 8 is 0.875. They're just two examples of expressing fractions as terminating decimals. Now let's have a look at something very interesting. Repeating or recurring decimals have numbers after the decimal point that go on forever. There is a definite pattern to this repetition. Let's have a look at some simple examples which will illustrate that fact. Express 1 over 3 as a repeating decimal. So we're dividing 3 into 1. So 3 into 1.0000. 3 into 1 goes 0. Put down the decimal point. 1 left over. 3 into 10 goes 3. Remainder 1. 3 into 10 goes 3, remainder 1. 3 into 10 goes 3, remainder 1. And 3 into 10 goes 3. So the answer above is 0. A lot of 3's keep repeating themselves. This can be written as 0.3 with a little dot here above the 3. That tells us that the 3 continues on. It keeps repeating or recurring. That's the short way of writing it. Let's have a look at some more examples on the next slide. Express 3 over 11 as a repeating decimal. So we're dividing 11 into 3. There's 11 divided into 3. Put down as many noughts as you want. 11 into 3 goes 0. Put down the decimal point. 3 left over. 11 into 30 goes 2. Remainder 8. 11 into 80 goes 7, remainder 3. 11 into 30 goes 2, remainder 8. 11 into 80 goes 7, remainder 3, etc. So you actually get, as the answer, which is here, this answer here, the 2 and the 7, 2, 7, 2, 7, they keep repeating. The short way of writing that is 0.27 with a dot above the 2 and a dot above the 7. When you do that, that tells you that the 2 and the 7 keep repeating. The next example, express 13 over 33 as a repeating decimal. So there it is, we're dividing 33 into 13. Put down as many zeros as you want. 33 into 13 goes 0. Put down the 13 here. 33 into 130 goes 3 times, with 31 left over. 33 into 310 goes 9 times, with 13 left over. 33 into 130 goes 3 times, with 31 left over. 33 into 310 goes 9 times, with 13 left over, and so on. So basically you get this decimal here, where you see that the 3 and the 9 keep repeating. And again, similar to this example, put a dot over the 3, a dot over the 9. That tells you that the 3 and the 9 keep repeating. This one is a little bit different. Convert 7/66 to a recurring decimal. So we have 7/66, which is 66 divided into 7. 66 into 7 goes 0 and 7 left over. 66 into 70 goes 1 and 4 left over. 66 into 40 goes 0 and 40 left over. 66 into 400 goes 6 times and 4 left over. 66 into 40 goes 0 and 40 left over. And 66 into 400 goes 6. So you can see you have 0.10606. The 06 keeps continuing. Okay, so the 06 keeps continuing on. So we just put the 1 down, and we put a dot over the 0 and a dot over the 6, which tells us that each of them, excuse me, continue on. So that's actually 0.106060606, and it goes on forever. So this video has introduced us to the idea of converting fractions to decimals, and we've seen how to convert fractions to terminating decimals, and we've also seen how to convert fractions to repeating or recurring decimals. It's quite straightforward, and the more practice you get, the better you'll be.